In this video, we're going to talk through functions using the simple f function as an example. So what we are looking at here is a function definition. And we are defining a function named f. The f function begins with its name, followed by a segment of a function we call a signature, which we'll break down into multiple components. So this is the signature. The signature is made up of parameters, which are contained inside of the curly braces here, and a return type. So let's talk about what these are. Parameters are the extra pieces of information that we must give a function in order for it to do its job. So these are the inputs of a function. So I'm going to call this input. And the return type tells us what kind of data we'll get out of this function after it's completed its job. So I'll call this the output type. And we'll take a look at how these come into play when a function gets called here shortly. What follows next in the definition is the arrow. And this is a specific way of defining a function. This arrow is saying, all right, now what follows is what happens when this function is called. So the implementation or the function body follows the implementation. And the implementation is a sequence of steps that this function will move through one by one in order to complete its job. And so what a function is it's a way for us to take a commonly used sequence of steps that has some input and some result, and to wrap them, bundle them up into some single unit of code that has a name, the name of the function. So how might we use this f function now that we've defined it? Well, I'm going to break down the bottom of this screen into two separate segments. And on the left-hand side here, I'm going to call this my code. And on the right-hand side, I'm going to call this the computer state. And let's talk about code first. Let's write a little program that uses this function f. So maybe we've got a program that has a variable declaration, like let y be a number variable. And so we've declared a variable y, and let's say y is assigned the result of calling the f function, and f has as an input a number parameter, so we need to give it a number argument. And then in order to see the result of this assignment statement, or to see what is stored inside of y, we'll run this print y function call to cause y's value to be displayed on the screen. So we can imagine we wrote this code perhaps in a main function or somewhere else in our program outside of the function f. Later, at some point, we go to run our code. And so the computer, when it runs the code, what it's going to do is it's going to first figure out, well, what is this f function? And it's going to sort of define that inside of itself, and it's going to know what f does. And then it's going to, at some point, reach this line of code in our program. And remember, the computer is going to move through these instructions or through these statements step by step. So the first thing it's going to do is this assignment statement here. On the CPU state side of this, this illustration, what I'm going to do is set up this segment, this part of my screen, into two areas. So I'm going to call this the code running. And technically we would call this the stack. So maybe I'll just assume that we call that the stack more technically. And then on the other side, I'll call this memory. All right. So the code that is running currently, the computer can only see one line of code at a time. So the line of code that it's trying to run right now is let y be a number. Right? And so this line of code is saying, in memory, we want to set up a space for variable y to exist. And so variable y is going to be some space in memory that, I'll just make a note, it can only hold numbers. So this is space that's been reserved. We have not yet put anything in it. Once this space is reserved, this line of code is complete. We are ready to move on to the next instruction. So what the computer does is it moves to here. And it's going to say, all right, the code that is currently running is the y is assigned f of 3. Now, we've reached this assignment statement. And an assignment statement has a few pieces to it. First, we need to figure out what is the value that's being assigned to the y variable. In order to do that, we need to call function f and evaluate its results. When a function is called, the computer does something special. It moves through a sequence of steps. The first thing it does is it drops a bookmark at this point in code, and it says, I'm going to come back to this line. I've still got work to do. And so what I'm going to do in my code running segment is say, all right, we're going to pause on this line of code. We've got to come back to this point, but let's go figure out what is the result of calling f of 3 first. Right, so I'm going to just make this in a special box. So what is the result of calling f of 3? And what we're going to do to figure that out is move through function call steps. The first step is we drop our bookmark. The second step is we take the argument 3 and assign it to the parameter x. It's as if in our code we are, for the purposes of this function, saying, all right, when we call this function, it's going to automatically have in its memory an x variable set up. X can hold a number. This is what a parameter means. Right? So after we've dropped this bookmark, the next thing we do is we set up space in memory for our parameters. We then take this 3 argument and we assign it to the x variable. So this step, you'll never actually see this in code, but the next thing the computer is going to do is it's going to assign its parameters. Here we have only one parameter. The parameter x is being assigned a value of 3. In order for the computer, and so right now we've got, this is where we are in our program. We are assigning the parameter 3, the value of 3 to our parameter x. And so to complete this, we don't have to figure out, well, 3 is just going to be stored in x. So x's value in memory is going to be 3. The next thing we're going to do after that line of completes, and remember, this is something that only happens when your program is running, is the computer will continue on into the function definition. And so it's going to move through the function step by step. And here we have only one step. We have a return step that is returning x times 2. So how is the computer going to evaluate this line of code? The first thing it needs to do is it needs to simplify for x here. Well, what is x? It's going to look up x in its memory. Its memory has 3 stored in it because that was the argument we gave it. So the next thing the computer is going to do is it's going to substitute that. Then it's going to need to figure out, well, what is 3 times 2? 3 times 2 is 6, so it's going to simplify to just 6. Now that our return statement has a single value that it's going to return back to the caller, the next interesting sequence of steps happens in our function call. We've reached the end of our function call because we've reached a return statement. And when we reach a return statement, what happens is we say, all right, replace wherever this call came from, wherever this bookmark was in our code, go back to that point, and now you have the answer to that. The answer to that function call is whatever value I'm returning here. So it's 6. So what happens is we are going to say, all right, we're going to replace this f of 3 call with a value of 6, and then we're going to effectively forget that we were ever inside of that function call f. We get rid of its variables and we stop running that line of code, and we return back to where we were in our code previously. We return back to our bookmark. All right, and so now the computer has simplified its assignment statement down to y is assigned 6, and we can store 6 in the y variable. Right? That line of code is now completed, so we're ready to move down to the next line of code. So the line of code that the computer is going to process next is print y. And the first thing it's going to do in this special function call is figure out, well, what is this y value? Y in memory is a value of 6, so the computer is going to substitute 6 when it evaluates this, and then it's going to call the print statement and the print function. The print function is just a simple special function that causes the value 6 to be displayed on the screen. What I want to emphasize here is that all we are ever going to see in our code editor is this program here. But when the computer is moving through its sequence of steps to resolve this program or to run it as the computer will run it, this is how it's going to move through code. It's going to be simplifying expressions down to singular values until it reaches some result.